Today I have a Yamaha with a strange problem. It won't stay turned on. So we're going to see if we can solve this problem. And this is an interesting one. And this affects many models of the same design. So what you see here is applicable for many models with the RXV series of Yamaha Dolby receivers. This is a Yamaha RXV470 receiver that was brought in. Don't know what the problem with it is, so let's turn it on and find out that it turns off. Turn it on and it turns off. So there's the problem. It will not stay turned on. Okay, so this one has a problem. Let's tear it apart. Through the magic of my electric screwdriver, the top is removed. Let's get a look in the top of this unit, or as Dave Jones would say, let's get a look up under the skirt. The fact that the unit is shutting off indicates that it's going into a protection mode of some type. But as to why it's going into protection, that's what we need to investigate. This being a Dolby Pro Logic receiver, there's going to be 5 amplifiers in this. Get your main left and right. It's going to have a center channel, and it's going to have a rear left and right. In this case, they're done by ICs on this. And the fault could be on any of these amplifiers. A fault detected on any of them will cause the unit to shut down. So the first thing we need to do is determine if there's a problem, if we're getting any voltage to the outputs, and if we've got any DC being fed to the speaker protection circuit on any of the outputs, because any DC voltage that is being detected is going to cause the unit to go into a full shutdown. So the first thing we're going to do is we're going to look to see if there's any DC voltage on either the collector or the base of the output transistors. Now you will have voltage on the collector. If I go to the collector, for example, there's minus 42 volts on this one. If we look on the emitter or the base, we'll see that there's no voltage here, and yet the amp still shuts down. Look over on the, this is normal as it's powering down, but as it stabilizes there is no voltage. This is our base, so we have our 0.6 volts. And the same over here. Our positive 0.6 volts. So we have no DC voltage on these outputs. So we know that the output is good. We'll do the same for the center channel. So no DC voltage there. We got to check the outputs for the rear channel. It doesn't appear to be DC voltages, so we may have a regulator problem, and it's missing one of the voltages for the preamp circuit. So we know right now that it is not a fault with any of the, I haven't checked both of the ICs here, but I'm assuming that they're probably okay, but it's not a transistor that's failed in the main amplifier section. I have a sneaking suspicion that our problem is probably a regulator that's not a good connection on one of the regulators. There's a regulator here. We'll just flex this board a bit here and see whether it still shuts off. Okay, speaker relay just clicked in. Aha! We may we got a connection problem on this thing. Something on this board. There's a connection. Because I just tap it slightly in it. If I press down on the board, and it shuts off. Now we got a connection. On this board here, there's a problem. Solder connection problem. For sure. See it stay going? As soon as I tap it, it'll shut off. Okay, so the problem's on this board. That's how we isolate this problem. We got a problem on this board here, and it's going to be a solder connection. Pretty much guarantee it's going to be a solder connection. So I have to remove this board to look at it. I think this one will come out. I just have to remove the clips here. The problem with these things is there's another board underneath it, so I can't see it from below. I actually have to remove this board. So I got to remove the speaker terminals, the video inputs, and then this board should lift up. I'll have to take out the screws here for the heat sinks, but I should be able to lift this board out and find the problem under here in this power supply. So remove the 4 screws to hold the connectors in. And there's a clip here. I'll take that out. And now I should be able just to remove these screws that hold the heatsink clamps in place. Guy that owns that radio, that old car radio I was working on, I thought it was in 1948. It was actually 1940. The guy that owns that was over today, so we were looking at it, giving him options. I've done, as I say, I did the capacitors. I know people have been jumping all over me about not changing out the vibrator snubber, but that actually was changed out. It just wasn't shown on video. What it needs is a power switch. And he is going to try and get a new power switch for it, as well as the plastic parts. He says apparently those parts are still available. There's replica parts available for it. So he's going to try and get those parts, and then we'll have a project of changing the volume control switch and some of the plastic parts on it, and finishing up the restoration. The reason he wants it repaired is not so much because he wants to use it, he wants to sell it. So he wants it as a working unit to sell. But again, we are limited as to what is going to be done on it, because he doesn't want to spend too much, because he's not going to necessarily get a huge rate of return for all the extra work. So the critical caps have been replaced on it, and the power switch will get replaced, and then I think that'll probably do that. But that'll be a future project once he's able to access the parts. Right now there's just none available. The borders are closed, so trying to get parts out of the States is not the easiest thing right now. But that'll be another project down the road. I'm interested in this regulator IC here. Also, these output ICs for the rear channel. Those are the components on this that interest me. I'm going to inspect the connections, get my magnifying glass on here so that I can get a good close-up look, and I'll get a close-up on the camera here momentarily. But something on this board is causing the problem. Oh, it's right here. This is regulator right over here. Get a load of the connections on this. There is the fault right there. You can see the cracks. That is why this one's not working. So we'll resolder this regulator. and this one over here at the front, and maybe the ICs. Take a look at them and see how they look. Oh yeah, look at the cracks. Look at all the cracks along here. See this? There's our fault. Broken solder. Let's fix it and get this one taken care of. Got a bit of a crow problem here. Reminds me of an old one. The Crow Mystery, if you haven't heard this one. Researchers for Massachusetts Turnpike Authority found about 200 dead crows near the greater Boston recently, and there was concern they may have died from avian flu. A bird pathologist examined the remains of all the crows and to everyone's relief confirmed that the problem was definitely not avian flu. The cause of the death appeared to be vehicular impact. However, during the detailed analysis was noticed that varying colors of paint appeared on the birds' beaks and claws, and by analyzing these paint residues, it was determined that 98% of the crows had been killed by impact with big trucks, and only 2 by impact with a car. MTA then hired an ornithologist behavioral to determine if there was a cause for the disappropriate percentage of truck kills versus cars. And the behaviors very quickly concluded the cause. You see, when a crow eats roadkill, they have a lookout crow in a nearby tree to warn of impending danger. And the scientific conclusion was that all the lookout crows could say caw, but not a single one could say truck. Wah, wah, wah. Just reminded me of that with all those crows out there making all that racket. You should hear it when the eagles and the crows get going, because the crows have been robbing the eagle's nest, and the eagles are not too happy. Speaking of crows, I was attacked by one the other day at work. I'm out working outside the house, and this bloody crow kept dive bombing me because I guess they have a nest nearby. And they didn't like the fact that I was working at the side of a house. And this crow was sitting on the power line watching me. And every so often he would dive bomb, fly down at me. So I had my customer was there with an umbrella, and he kept opening the umbrella. Every time the crow would fly down, he had this big umbrella, and he'd flip the thing open to scare the bird away. Because apparently this bird is a nasty bird and has attacked people. No, that's not going to work now, is it? We have a bit of a bridge here. A bridge over troubled circuit board. This is not lead-free solder I'm working with, but the board itself was done with lead-free solder originally. Like all the modern crap. That's why this breaks. Got another one here on this regulator. This one doesn't look too bad, but I will redo it anyway since I've got the board out. You notice there's a little indentation here. That's actually to push down that little transistor that is used for temperature compensation. You'll notice that there's a couple more of them down. Where are they here? There's another one here, and another one over there. And what those are for is those are for the bias compensation. So as a transistor heats up, the internal leakage goes up. So they use the temperature compensation, or the temperature coefficients, I should say, of the silicon junction of a transistor to determine how much leakage is taking place, and use that to adjust the bias accordingly, to drop the bias so that the transistor doesn't go into thermal runaway. A lot of these amplifiers use a variable bias. Yamaha is one company that does it. Sony does it too. They're legato linear. Techniques call theirs new class A. But basically what it is it's a variable bias that increases the bias to the push-pull class B amplifier, which all these are, because they have a transistor for positive and a transistor for negative. What it does is it increases the bias voltage at low volumes, and what this does is it keeps the transistor from going into cutoff and pushes it more into the linear. It's a pseudo class A. A real class A amplifier has a single-ended output, so there's just one transistor or one tube, which are very inefficient but very clean, and everything else uses two. Here they are here. You got a positive and a negative for each channel. Positive and negative. Positive, negative. So each transistor amplifies half of the waveform, which means that as the waveform is going up and down, you're switching from one to the other. And at that crossover point, if the transistor goes into cutoff, you get nasty distortion called crossover distortion, which gives you some pretty nasty sounding odd order harmonics. So in an attempt to keep electric bikes going by now. So in an attempt to keep that distortion as low as possible, they apply a slight bias voltage to both the transistors to keep the transistor from going into or going out of conduction until at least the other transistor is handling current. So the positive going transistor is kept into conduction slightly into the negative transistor's transition, and then the positive transistor will go into cutoff. So the transistor comes out of cutoff before the other one goes into cutoff. That reduces the distortion, but there is still some distortion there. And the distortion is much more audible at low volumes than it is at high volumes, just because of the way the human ear perceives distortion. So what a lot of amplifier manufacturers and designers do is they use a variable bias that increases the bias to the transistors under low sound levels. And this one here may not have a variable bias on it. It still has temperature compensation, but a lot of them will have a variable bias. The new Class A Technics, the linear, legato, Sony's, for example, where they will push at low volume levels, they will push both transistors into higher saturation. So there's current flowing through the transistors. Even if there's no sound being produced, there's still a fair number of milliwatts flowing through each transistor. The transistors are kept biased on, not just past cutoff, but actually into a semi-conductive state. This pushes the distortion much lower. And of course, when you have an amplifier like that, it is even more critical that you monitor the temperature, because if you have thermal runaway, it's going to go out of control a lot quicker if you've got bias going or got current flowing through the transistor junctions at low volumes. Okay, ready for our first test. Power on. We have sound. Let's tune to a different station. I don't have an antenna on here, so we're not going to hear much. I'll just tune to my test transmitter. If this will, in fact, go down to 87.5, which it does. Test channel, left channel, center, there's no speaker, right channel, it's surround. There we go. This one is fixed. So if you have one of these Yamaha RXV470 or any of this series, any of the RXV series of amplifiers, and you have a problem where when you press the power button it shuts off right away, check the connections under here, the ICs and the 2 regulators, because that's a good chance that's where your fault is. Anyway, that's all it is for this one. Thanks for watching. We'll catch you again in the next one real soon. Bye for now.